Hi everybody, my name is Channing Hunter. I'm a sophomore here at Washington University, double majoring in chemistry and math with a minor in physics. And my PI's name is Richard Mabs in the chem department here. And today I'm going to talk to you about my preliminary summer project, which is the cluster anion study of the chemical reduction of carbon dioxide, which is a fancy way of saying making negatively charged molecules and seeing if we can get an electron to transfer to carbon dioxide. And so we use this machine down here on the bottom right to do our experimentation. And from that, we flow carbon dioxide through tubing, and then we put enough energy in to vaporize the copper. That's solid. From there, we make anions, which are basically negatively charged molecules, and each of these has a different mass. And then they go into, in essence, a smaller tube where a laser photo detaches or moves the electron, and we image them. So the images we get look like these beautiful images right here. And we were able to get different results this summer, one of which was centered around the oxygen group, which is these three graphs here. And as you see, majority of the graphs have no movement at all, or there's nothing different about them. So from that, we can say the electron is remaining in a similar position most of the time. And so in this case, it's remaining around the oxygen. And so that's bad because we want the electron to transfer to the carbon dioxide. However, when we tried this with copper, we were able to make this here, which is CuO2F. The white part here is an extra electron. The silver ball here is copper. The red is oxygen, and the green is fluorine. And from there, we were able to bond it to carbon dioxide. So the picture looks like this. And as you can see, the difference in the graphs indicate that the carbon dioxide is most likely bonded. So what you have is a carbon dioxide generally looks like this, comes and interacts with this molecule here. And the result is a bent carbon dioxide, which then can bond, and we make this. So this is our final product, which is the copper, the two oxygens, and the fluorine bonded to our carbon dioxide, so carbon and two oxygens. And from here, as I said earlier, the graphs are different, and so we can tell that the carbon dioxide is most likely bonded. And from there, in terms of future experiments, what we hope to do is see if we can use different metals and transfer electrons to the carbon dioxide. We also want to see if we can add water and see how that affects the number of carbon dioxides that bond to the particular group here. We want to check for the spectra of this particular molecule on its own to see if we do indeed have bonding or solvation. And we want to increase the pressure to see how many carbon dioxides we can bond to groups like this.